Welcome to Study Loop.
This is the answer to Chapter 13, problem number 52 from the Smith Organic Chemistry textbook. And so this problem is asking us to treat benzonitrile with two different reducing agents and to predict the products of each of those reductions based on mass spec and IR data that were given. And so treatment of benzonitrile with lithium aluminum hydride and then water gives us K. And so immediately, unfortunately, in organic chemistry, you do just have to learn and memorize reagents and what they do to particular starting materials. So when you see this nitrile treated with lithium aluminum hydride, and then water, you should immediately think, okay, that's going to become an amine. And you should be able to accurately predict the product K, which I've drawn down here, just based on the reaction conditions. So then you can look at the spectral data that you're given and see if that correlates with your prediction. And so a molecular ion of 107, since that's an odd number, that should tell us that we have an odd number of nitrogens in our product. And we do, based on what I've drawn here. And so we would do the math. 107 minus 14 for that one nitrogen is going to leave us with 93. If we choose to account for that with 7 carbons, that leaves us space for 9 hydrogens for a formula of C7H9N. Again, that agrees with what I've drawn down here. And then looking at the IR data, these first two peaks correspond to nitrogen-hydrogen bonds from this primary amine. This peak at 3062 is CsP2H bonds from the carbons in the ring and their hydrogens. 2920, CsP3H. So there are 2 hydrogens on this carbon here. That's off the ring. So that's where they come from. That's where that peak comes from. And then 1600, of course, is your aromatic ring. And so that's K accounted for. So then it doesn't tell us what conditions really. It just says a milder reducing agent. So we can't start from an accurate prediction of a molecule. This time it's a little harder because we don't know exactly what we're reducing with. So we should start with the spectral data. So we have a molecular ion at 106. So this is an even number. So this tells us that we have no nitrogens or an even number of nitrogens. So we start with 1 nitrogen, and without knowing what our reagent is, it's pretty safe to say that it's probably not going to add a single nitrogen or 3 nitrogens, and it's much more likely that we will lose this nitrogen to get to an even number. Because remember, if it was an odd number, it would be an odd number of nitrogens. But since it's an even number, we can assume no nitrogens or an even number of nitrogens. And in this case, no nitrogens is much more likely. We're also told that we have fragments in the mass spec corresponding to 105 and 77. And that 77, whenever you see it in a mass spec, it's not always benzene, but benzene is 77. So, you should think right off the bat, hey, maybe that's a benzene ion in my mass spec. And so then we'll look at the IR. So we have a peak for CsP2H bonds, a peak for CsP3H bonds. These 2 peaks, 2820 and 2736. So apparently, according to Appendix E in the back of this textbook, These two peaks are from the CH bond of an aldehyde, but you probably wouldn't know that without looking in that appendix. But 1703, you should definitely know, is a carbon-oxygen double bond. And then, of course, 1600 again is our aromatic ring. So knowing that we have a carbonyl at least, because again, you might not know these two aldehyde peaks. So we know that we have a carbonyl. We're just doing a reduction, so we're probably not adding carbons. There's only this one carbon that's not part of the aromatic ring system. So it makes the most sense to put the carbonyl on this carbon. So that's what I've drawn here for L. It agrees with all the spectral data that we have, the mass spec and the IR. And furthermore, to account for these fragments at 105 and 77, if we consider what alpha cleavage in a mass spec of this molecule would look like, we would get these two fragments that I've drawn here. And pardon me, I did not label this one. But so there is our benzene, which I just labeled. That's going to be your 77, like I said initially when we first saw it. And then alpha cleavage on the other side of the carbonyl is just going to remove a hydrogen. So that's going to be your 105. From 106, the molecular ion, if you lose one hydrogen, that would take you to 105. And so I think it's a pretty safe bet that this is L. And again, we solved K pretty easily just by knowing what lithium aluminum hydride does to a nitrile. And so that is the answer to chapter 13, problem number 52.